I'm delighted to be with you today for the Start Here for Space series, Watch Out for Space Debris. My name is Carolyn Belle, and I'm the Director of Advanced Systems at Astroscale US. So today we will be talking all about space debris and space sustainability. What is space debris? What have been significant collisions, breakups, and their implications for the space environment? What is the growing trend that is leading us to be talking about space debris today in this series? What is the trajectory for space sustainability moving forward? And how do we take action? How do we take steps in developing technology, writing policies, and crafting economics that support space sustainability and the ongoing utilization of space? And then we'll close with some key takeaways and a message for moving forward together in the industry. So let's start at the beginning. What is space debris? So space debris is a non-operational or defunct object, including fragments, that's either in space or that's re-entering the atmosphere. That could include something as large as an upper stage rocket body or as small as a chip of paint. We also have defunct satellites that contribute to space debris. Objects that are released during normal operations. This could be a tool that an astronaut accidentally releases during an extravehicular activity. In-orbit fragmentations also contribute to debris, and there are a few subcategories of in-orbit fragmentations that drive this. So one is breakups in orbit, whether that's an intentional breakup, such as an anti-satellite test, or an unintentional breakup, such as a propellant tank that explodes on orbit. Fragmentations also result from collisions. As soon as you have two objects in space that move towards each other and collide at very high speeds, that collision will generate new pieces of space debris, whether those original objects were themselves pieces of debris or whether they were active satellites delivering services. Aside from human sources of debris, such as what we just stepped through, there are also natural sources of space debris, and that could be meteoroids or micrometeoroids. So when we talk space debris, we're really talking about any object that is moving through the space environment where we're operating satellites that could have an impact on those operational spacecraft. It's important to remember that anything in space is moving very, very quickly. And so even if it's a very small object, that speed, that velocity that it has in whatever orbit it's moving in can have a significant impact when it or if it does collide with something else. So why do we care about space debris? Just because it's up there, why do we need to talk about it? Well, it all goes back to why we use space to begin with. Today's society, today's economic infrastructure and services depend on space systems. We talk about weather forecasts that are derived from satellites, GPS for navigation, the timing signals that are used for banking transactions, any sort of ATM or chip card transaction, remote and emergency communications, especially after disasters, Earth observation and imagery that's collected for resource management and agriculture. All of these are important services that are delivered by satellites that rely on a clean space environment in which to operate. The challenge is that debris that's in orbit poses a direct risk to those satellites. And if there is a collision, it could be catastrophic, right? It could completely destroy the spacecraft, or it could be a smaller collision that doesn't destroy the spacecraft, but could damage it, say by impacting a solar array and reducing the amount of power that's available for that satellite to do its job, or it could completely disable one of the core systems on that spacecraft, but not totally destroy it, but at some level reduce the ability of that spacecraft to provide viable services. And the more congested the orbital environment becomes, whether that is congestion due to more satellites or to more debris, the higher and the greater the operational burden that we see on spacecraft operators to monitor that debris, to decide when and how to maneuver around that debris, and really to hold the ongoing risk that's created by that congested environment. It's important to understand just how powerful this debris is. So I included this picture here, which is of the Canadarm, which is a robotic arm. It's mounted to the outside of the International Space Station. And recently, it was noticed that it was impacted by a piece of debris, and there was actually a hole pierced through the Canadarm. Now, this was a lucky one because it is still functional. It is very important for ongoing operations of the space station. So that was lucky. However, it's a stark reminder of how pervasive this threat of space debris is, and especially when we're talking about humans in space on the ISS. It's a risk we need to take into account. In 2020, there were 3 separate times that the astronauts on the space station had to go into one of the capsules for safety because there was a collision risk that was presented to the ISS. And as we seek to expand the number of people who are operating in space, the number of satellites operating, it's an important reminder that we don't want to be doing that so regularly. There have been some significant collisions and breakups in orbit. There have been 2 breakups this year already. 2 weather satellites in 2021 have had a breakup that created new debris. We look back at specific examples to understand and model how debris moves through the space environment. So what I'm showing you here is 2009. There was a collision between an Iridium communication satellite, so an American communication satellite actively delivering services, and Cosmos, which was a no longer operational Russian government satellite. So these 2 spacecraft collided. They were not on similar orbits. You can see the image here on the left. One of theirs orbit is modeled in blue, one is modeled in yellow. So they simply crossed each other, and there unfortunately was a collision. Now, the collision destroyed both spacecraft. It created a lot of objects of space debris. Originally, those pieces of debris were in the orbit of the original satellite. So think of a bunch of lanes on a highway. It was just a bunch of cars in a single lane moving forward in its original orbit. But over time, even though space is large, those pieces of debris start to slightly alter their orbits. And so you get, with weeks to months and certainly over years, to this image on the right, which is the model of what that debris distribution was like sometime after the original collision. And you can see that those blue and those yellow dots are no longer in that neat line. They've actually expanded to cover a much larger swath of orbits, which means that they're having an impact on many more operational satellites that are moving through those really important low Earth orbits. Now, the number of objects in space has grown over time. So I wanted to share with you a model of that over time. And so there are a few things to look for in this when I started the video. Green dots, active satellites. So at the time that they're modeled here, that's actively delivering a service. Yellow dots, inactive satellites that have not been removed from orbit. So essentially those are pieces of space debris. And then red dots are those fragments and what we call debris. So if we look at the start of the space age, 1957, the first satellite launched, not a lot in orbit. But over time, as more satellites are launched, as more satellites are left in orbit, as more debris is created, we see this growing number of objects in space. This trend, if we want to look at the numbers here, the number of objects that we can observe in space, so that we can either observe from the ground with telescopes, with radars, or from space, around 21,000 of those are debris fragments. About 2,000, 1950 are discarded rocket bodies that have been left in space. Almost 3,000 are defunct satellites, so no longer in use. And only 2,700 are operational satellites that are delivering services to us today. So that's a small segment of the overall objects in space. And that's only what we can observe. If we model out the fragmentation that's expected, that we just can't observe because of our deployed technologies today, we hit 130 million fragments of debris that are posing at risk in space. So what is driving this growing trend of risk and why we're talking about space sustainability now? Well, a few things. More launches. We have seen cheaper launches become available and easier to access, which is really exciting. We've seen the use of satellite constellations. A constellation is a proliferated model of operating in space. So instead of having one large satellite, you might have a number of smaller satellites providing a service. And we also see the deployment of new and different applications and services being provided from space, which is also really exciting. We're no longer limited to just using space for communications, but we can use space for a vast number of services and applications on the Earth, which delivers value to many more segments of society. But that also means we have more satellites in space to deliver those diverse services. So all of that together drives this increase in launch rate that we've seen. So a tenfold increase in the last decade alone, and that will only continue to increase as we move forward. The other element that factors into this growing trend of orbital debris is changes in design, how we build satellites. We've seen more small satellites launched relative to the larger ones that had been popular. We see shorter life cycles, which is important because it means that if a satellite is only operating for 5 years instead of 10 years, you need to replace it twice as often, which means more satellites being put into space. And we also see less robust systems that are designed. There are many more off-the-shelf components rather than the traditional space-hardened components, which brings benefits and challenges. So of this growing trend, looking at this vast increase in the benefit that we can derive from space, but at the same time, the challenges that are posed by more satellites, more debris in space, comes this question of space sustainability. And that's what I want to talk to you about now. What is the trajectory of space sustainability? So Astroscale, the company that I work for, was founded with this specific mission to provide for space sustainability and to work with partners across the ecosystem. And we've seen more companies, more agencies start to talk about this concept of space sustainability. If we look back in the late 80s, the United Nations did a study on sustainable development. So not focused on space, though they did touch on it. And there they said that sustainable development was a development that meets the needs of current generations, so us here today, without compromising the ability of future generations to meet their own needs. And when we apply this idea to space, it's really enabling this long-term access to all orbits, whether that's low Earth orbit, geostationary orbit, further out to cislunar, as well as freedom of operation in space, so being able to move between those orbits and move and provide the services that you want to from space for ongoing exploration, ongoing science, ongoing national security, ongoing commercial benefit and utilization of space, so that we can continue to do that today, and our kids, our grandkids, 100 years from now, people can continue to use space, and hopefully we have an expanded way of using space by then. So the idea of sustainability really comes to balance. How do we balance the interests of people, so the people involved in the space industry, as well as the people who derive benefit from our operations in space? How do we balance that with the planet, or in this case, the Earth's orbit and the orbital environment, and profit? And that could be commercial profit. It also could be science return, national security return, whatever the purpose of the mission is. What is the benefit we derive from that? And how do we make sure that we're getting as much out of each of those without seriously hampering the other as possible for this long-term use? So there are a few steps that we need to take to really start this space sustainability era. Remediation. We need to remediate the debris that is already in orbit. All of those red dots that were on that model before of space debris, can we remove some of those, or at least the larger pieces, the threatening pieces of debris? Can we mitigate the creation of future debris? As we're designing satellites, systems, rockets, how do we do it in a way that creates as little debris as possible moving forward? And finally, how do we maximize the utility of every single satellite that's placed in orbit? Let's get the most out of each one of those as possible once we put it into space. To do this, there are 3 different areas where we need to focus our efforts. And so this is really a cross-industry, cross-disciplinary effort to address space sustainability. So it brings in a lot of people, a lot of areas of expertise. The first one let's talk about is technology. We think of space, we think of technology. So how do we develop a roadmap of innovative capabilities that can lead to sustainability? We can design satellites to be deorbited at the end of their life. So this means what we call post-mission disposal solutions. For satellites in low Earth orbit, we remove them from orbit by lowering their altitude enough that they get slowed down in the atmosphere and will eventually burn up. So to do that, we could put propulsion on satellites. We could put tethers on satellites. We could put drag sails on satellites. There are a number of different options to remove that satellite from orbit with what you're equipping it with before you launch it. We also need to passivate satellites at end of life, which means we drain the batteries and vent all remaining propellant so that there's no energy that's stored in the satellite that could create some sort of explosion and debris creating event after it's taken out of service. And the other element that factors into designing satellites for deorbit is preparing for the unexpected. So even if there is a deorbit solution on board the satellite, if there is a significant anomaly that the satellite can't be commanded or that system fails, is there an alternative to still be able to remove that satellite from orbit? So preparing these satellites with docking interfaces so that there's some way for another spacecraft to come dock with that satellite and remove it from orbit. Which leads us into this next area of technology that needs to be developed, which is servicing in space. Now, servicing could mean a variety of different things, and it ultimately will as we develop this more dynamic in-space economy. It could mean end-of-life removal, like I just mentioned, for satellites that for whatever reason cannot remove themselves from their orbits. So to keep orbits clean, you send up a servicer, it docks with that defunct satellite and removes it from orbit. We also need servicers who are capable of active debris removal, which means going after those pieces of debris that are already in space. They weren't prepared to be removed by a servicer, but is there a way that we can still remove those satellites from space? And that's something that we're working on now. There's also services that could extend the life of satellites. Say you have a satellite that runs out of fuel, but otherwise is still functioning. Is there a way that you can refuel that satellite or stabilize it in its orbit so that it can continue to provide viable services for a longer period of time? Is there a way that you can adapt a satellite when it's in orbit using a servicing vehicle so that it can deliver a more competitive service for that context in time? To do these servicing efforts, we need to develop core servicing technology. There are a few pieces of technology that are really critical here. So one is what we call rendezvous and proximity operations. So the ability to have two satellites in very close proximity to each other and safely operate in that environment without colliding. We also need to have advanced sensing suites on board these servicing spacecraft so that as they are maneuvering in space, they can very astutely observe the satellite that they'll be servicing, can potentially inspect it and diagnose problems with it if there's an option to repair those problems so that the satellite can remain in service, being able to detect all of that through sensors. Docking is another key element. So whether that's prepared docking with an interface or unprepared docking with something that was never designed to be grabbed onto by a servicing satellite. And then the other element that's important is maneuvering in space once you have two satellites docked together, as well as how do you add as much autonomy into this process as possible, which will help with the economics piece that we'll get to in a minute. Policy is another area that demands attention as we look towards this space sustainability era. So how do we guide responsible space behavior through smart policy? We need a national strategy for what we call space environmental management. And this can encompass debris monitoring. It can also encompass space traffic management. You know, on the Earth, we have air traffic management. So having the same idea in space to monitor satellites as they maneuver and to coordinate those. We also need international dialogue. Let's remember that space is a global environment with players from around the world and more players with time. So we need to have this international dialogue across not only government entities, agencies, but also industry and trade associations. You know, any stakeholders, any satellite operators, you know, to come to the table and have these conversations around information sharing, around coordination, around standards, best practices, norms of behavior, liability, topics that factor into this conversation. Having a more robust discussion around those will be an important part of policy building. And then the other element of policy that's important to think about are how do we build positive incentives for sustainable commercial operations. Any satellite that's placed into space is licensed by some government entity somewhere. And so, in the US, that is the FAA for launch, that's the FCC for operations. There might be additional licenses depending on what your payload is, what it's observing. But how do those licensing agencies, structure their processes in a way that, promotes sustainable operations, right? So how do you measure risk? How do you limit risk when you're looking at an application of a satellite system to be launched? So if you look at a single satellite system that wants to be launched, okay, it's the risk of that one satellite. If you look at a system proposed that is 20,000 satellites, you need to look at that 20,000 satellite system and look at the aggregate probability of collision, as we call it, that is posed by that system as a whole. After the license has been granted, it's also important to continue to monitor that risk. Is the system behaving as was expected by the satellite operator when they designed it? So having health check-ins to make sure that everything is moving as expected, and if not, to adjust course. And we also need to ensure responsible disposal at the end of the mission. Today, there is a guideline of 25 years. So that means after a satellite's mission has ended, the guideline is that you have 25 years to remove it from orbit. It's only a guideline. It's not a rule. It's not a law. So no one is firmly held to that. But given the number of satellites that are launching today, 25 years is simply too long. So we propose that timeline be shortened to as soon as possible after the mission has been completed, but no more than 5 years to remove itself from orbit. The last piece that I want to talk about relative to how do we build towards sustainability is economics. How do we create incentives alongside cost-effective solutions that make satellite operators want to be sustainable? Not that it's an onerous burden that's placed on them that they feel like they have to be, but something they want to do because it makes them more competitive, more profitable. So how do we incentivize mission design in a way that mitigates the creation of new debris? How do we demonstrate the value of sustainable operations to the bottom line, right? So how do we look at changing the CapEx and the OpEx, the capital expenses and the operating expenses of a company to potentially reduce those expenses, to balance them out, to change them over time in a way that supports better cash flow for the company? How do you use space services to do that? Can you use space services and sustainability to increase revenue? So say you operate a satellite for an additional 5 years after its end of life by extending it, 5 years more revenue. So how does that impact the bottom line? And there's another element that flows through here that will, certainly come up, across the Start Here for Space series, which is the question of risk. How much risk is posed by the number of objects in the space environment today, and how does that risk impact the bottom line of the company? How does it impact their operations and how often they need to maneuver, or how much insurance they need to carry on a satellite? There are a variety of different factors that stem from this question of risk, something we always focus on in the industry. The other side to positive economic incentives for satellite operators, aside from the bottom line, is how do you make sustainable operations a competitive advantage? So how do you potentially gain asset flexibility through satellite servicing capabilities and the ability to potentially repurpose a satellite for something different if your market unexpectedly changes? Can you respond more quickly than a competitor if you have that flexibility built into your system? Or can you do it more cost effectively than a competitor? Is there an option to enhance service quality by operating in a more sustainable environment, right? Anytime that there is a significant collision risk and a satellite needs to maneuver, does it impact the quality of service provided to customers? And if you didn't have to do such frequent maneuvers, would you provide better quality of service and therefore, have a more competitive offering to your customers? And then the other piece that's becoming more and more important in the terrestrial environment, and it equally applies to space, is that of ESG, so the environment, social, governance goals that are starting to become really important, levers for the investment community, the financial community, as well as consumers in terms of how they make decisions for which companies to support, which companies to invest in. And so that will play out in space as well. So, we've talked through the challenge that's posed by debris, the threat, the many steps ahead of us to build towards a more sustainable environment. There's a lot of work to be done. But that being said, progress has been made on taking action, which is really exciting to see, especially in the last few years. So we have a few space agencies, the European Space Agency, as well as the Japanese Aerospace Exploration Agency. Both of them have missions under contract with a commercial partner to remove space debris, which is really exciting. The United Kingdom Space Agency, just within the last few weeks, announced a call to inquire with industry about how they would design a active debris removal mission themselves. And then in the US, we see efforts by NASA as well as DARPA to focus on more that satellite servicing technology of how do we rendezvous, dock with, maneuver, service satellites in space that ultimately will lead to other elements of that sustainable space operation. But it's not limited to government. And an important element of this is that we need to have engagement across government and industry. And we've started to see that. So, companies like Astroscale being founded, we have a mission on orbit today that is demonstrating debris removal capabilities. We're excited to share more of that in the coming months. And then we also have the companies that operate in space starting to make choices that will lay the foundation for a sustainable future in space. So a great example of that is OneWeb. They're one of the largest commercial operators in terms of number of satellites. They're building a large LEO constellation for broadband connectivity. And they have decided to equip their next generation of satellites with a docking interface. They don't need it today. They might not need it tomorrow because the satellites are capable of removing themselves from orbit. But in the off chance that there's an anomaly and one of those satellites can't remove itself from orbit, they have placed a docking interface on it so that satellite can be serviced to ensure that they're being a responsible space actor. So it's really exciting for us to see companies start to take these steps. Overall, space debris is a global challenge in an environment that everyone wants to use and potentially go to, visit one day, but nobody owns it. Managing that debris environment demands a concerted effort that blends technology, it blends policy and regulatory efforts, and economic and business approaches to really reach a robust solution. And remember, the earlier we address space debris, the more manageable it will be long-term. Thank you so much for joining us today for this Start Here for Space session on space debris and sustainability. And I look forward to discussing it with you in the future. Thanks so much.